Hello, welcome to presentation of final project in the course Pattern Recognition and Intelligent Systems. I am Sanket Sadanan Nayak, and I will be presenting my project, which was about study and analysis of clustering techniques. The project mainly dealt with following three problems. The first was to analyze different clustering algorithms to determine which clustering algorithm would help us with the FIFA 2020 data set in the question. So, uh, in this project, I have studied mainly three algorithms, that is naive k means, hierarchical clustering, and expectation maximization clustering algorithm. So, after a thorough analysis of all these three algorithms, uh, I have used a modified version of k-means algorithm, which is also known as k-means plus plus clustering, to identify the FIFA 2020 players uh, based on their play style and their attributes and skills. Moreover, the another goal of this project was to showcase that uh, in k-means clustering, it is very important to identify the right number of clusters, that is right value of k, uh, and how choice of k affects the classification uh, of the data under each cluster, uh, in this case according to their play type. So yeah. uh, so now I will talk about the existing approaches that I have used uh, to analyze data and to perform clustering. So, in my project, I have performed these three clustering algorithms. Firstly, on toy datasets. So, these toy datasets are basically small size datasets, which using which I have calculated accuracy for all these three clustering algorithms. One of the advantages of this toy dataset was that each data point in these algorithms were labeled, and the output of the clustering algorithm was compared with these actual labels. And yeah, the difference between their probabilistic labels and actual labels uh, showed how accurate each of these algorithms were. So now I would like to talk a bit about each of these algorithms in detail. So yeah, the core idea behind naive k-means clustering is that it just divides the dataset into k distinct non-overlapping clusters. So it was first put forth by Lloyd, and hence it is also known as Lloyd's algorithm. And yeah, in k-means clustering, it is important to calculate Euclidean distances for each of the centroids in each cluster, and this is done using a factor called WCSS, called within cluster sum of squares. So it's basically sum of Euclidean distances between the actual centroids and the centroids given out by this particular k-means clustering algorithm. Uh, as mentioned, the another version of k-means algorithm that is used in this project, uh, known as k-means plus plus, provides an advantage of upper bound over the existing WCSS cluster centroids, and hence it allows initialization of the cluster centroids in a specific manner. The next clustering algorithm that I would like to discuss is hierarchical clustering. Uh, since we know in k-means clustering, one of the biggest disadvantage of this algorithm is that uh, the number of clusters is required to be pre-specified. But in case of hierarchical clustering, uh, there is no need to pre-specify a number. Instead, hierarchical technique arranges the data from the data set in form of a tree, also known as dendrogram. And yes, there are two approaches in this case. The first is the agglomerative clustering, in which the whole data set begins as a uh, in which each of the points in data set begin as a cluster, and then they are merged in an iterative manner to get the desired optimum clusters. The second approach to this is using divisive clustering, in which the whole data set begins as a one single giant cluster and is then divided into several cluster as per the requirements of the use case. And uh, yeah, the last clustering algorithm is expectation maximization. The expectation maximization algorithm is basically a super version of model clustering, and is extended with the assumption that the data set is generated using a combination of probabilistic distributions. So since there are probabilistic distributions, uh, the components in this particular model are assumed to be Gaussian, and hence it is also called as Gaussian mixture model. And yeah, expectation maximization algorithm is kind of a generalized algorithm, uh, over k-means algorithm. So the expectation step in this algorithm is analogous to allocating data points to clusters in k-means, whereas the maximization step is analogous to changes of cluster centroids. One another key important thing over here is to discuss the elbow method, uh, which we use in case of k-means clustering to determine the appropriate value of k. And yes, this is used in performance evaluation of FIFA 2020 dataset, which is the primary goal of this project, primary as well as practical goal of this project. And yeah, before that, I would like to explain the evaluation of toy datasets using S datasets and spiral datasets. So, in case of clustering on S sets, I have used a contingency matrix which matches with the frequency of actual label to a given predicted label by the output of cl- clustering algorithm. And yeah, in several cases, in several sets that have been used in this project, the k-means algorithm has performed better than the hierarchical algorithm. And yeah, that's why I have chosen to go ahead with the k-means algorithm for my FIFA 2020 dataset. And because it showed higher a higher accuracy uh, on both the S sets and the spiral data sets. And yeah, in case of spiral data set, the accuracy was on the bit on the lower side. But yes, for the simplicity purpose of simplicity, we have used k-means plus plus algorithm, which provides more accuracy. So yeah. And so using elbow method, we determine that there can be three values of k, that is 3, 4 and 5. And yeah, in the conclusion of this project, I think it's very important to determine the right value of k, uh, which helps with stakeholders, that is managers, owners, and leagues of football clubs, to identify right players in each of the category. So when I use three number of clusters in k-means algorithm to analyze the data was absolutely divided into just the first cluster 0 over here. uh, they represent center forwards. They can be midfielders or strikers. In the second cluster, they are merely defenders, or they can be again center backs or left backs. So again, this is you know not clearly defined. And in case of second cluster 2, this is for goalkeepers. When I take the value of k as 4, uh, the categorization is bit more structured. And here we can see that defenders have more attributes allocated to them, whereas we have another new type of cluster, uh, that is center fielders, midfielders. And yes, when we take k is equal to 5, I think that is when this data uh, provides a lot of information. Here we have defenders as well as strikers, and then we have goalkeepers, and as well as center forwards, which were absolutely defined in k is equal to 3 and k is equal to 4, but then they are clearly defined here in k is equal to 5. So yeah, it's very important to choose right value of k. So thank you for listening to this presentation.